All right, everyone. Let's go ahead and get started. Thank you for joining today's webinar. As a brief introduction, my name is Nate Spurley, and I'm joined today with my colleague, Gary Yang. I am a technical sales engineer at RISA, and Gary is a senior product engineer at RISA. We are so very excited to be going over the latest features and improvements in version 21 of Adapt Builder. We're very confident that this new release will not only make Adapt Builder easier to use, but will also save you countless hours, and I mean countless hours of work, and improve the accuracy of your designs. Oh, come on, next slide. Awesome, there we go. So before we jump into things, please be aware that you can connect to the audio using your computer or even by simply calling in. Also, please feel free to use the Q&A chat box to ask any questions that you have that may come up while Gary and I are discussing. We have other engineers standing by to answer your questions. So I'm going to jump into the program here in just a moment, but first let's mention some of the new features that sort of work behind the scenes and don't have much to look at within the program, so to speak. So we have enhanced the map banded tool to allow users to pick up or whether the program should target to balance, self-weight, or both self-weight and dead load. This can help you get a much closer starting point for your banded tendons. This tool also now has a trim extend tolerance that kind of works behind the scenes and should remove a lot of the short tendon profiles that kind of plagued our models when you had a column that was close to a slab edge, kind of like the situation in that picture shown to the right. Often we'd map a banded tendon and it would add a high point at that column, and then it would also add a control point at the slab edge, and you'd get this tiny little reverse parabolic profile, and then you'd go through and have to delete that. With this kind of new tolerance feature that works behind the scenes, a lot of those should go away. We've also added a new help menu, which contains an all new help file. The help file has a ton of program information and references. For those of you that use other RISA programs, this will look very familiar. This help file will be an amazing resource for those that are new to Builder, as well as even users that are experienced. For example, I've used Builder for several years, and I'm already finding myself using this help file regularly to help remind me, what some of the settings do when I'm jumping into, for example, the criteria window, which has a plethora of settings, and I can't remember exactly what that one checkbox does that I haven't touched in a couple of months. So this help file is super, super beneficial. Lastly, the other major addition is the 2818 Australian code. That's a great addition that is probably going to make a lot of our users happy that are designing, based off of that code. And of course, there are a ton of fixes and other enhancements as well that we could sit here and talk about them all day. But rather, I invite you to read through our release notes if you want to find out more. But let's go ahead and jump into the program and really talk about the features that I think I'm most excited about. So hopefully you guys can still see my Builder screen. You can see I got a rather large Builder model here, right? You can kind of tell that we have a couple, simply because we have a couple of pore strips. It's got some rather complex geometry going on. We got a lot of jogs in the slab. We got a kind of thickening or slab transition area. It looks like, some cutouts for stairs or elevators. And then we also have some slab openings. And in fact, down here, this is actually a depressed slab region, and it's not modeled as an opening. In fact, let me go ahead and pop into a rendered view real quick, and you can kind of see, yeah, we have kind of this slab opening here, which there's just an additional portion of slab modeled in this area. It's not modeled as an opening element within the program. So I have added my banded tendon direction, simply using, my map banded tool that we kind of discussed. And I've gone ahead and done some tweaks here and there. I've actually gone ahead as well to add tendons in this location, for example. And I've also had I've added some tendons in this location to kind of split this kind of in a Y shape, just to kind of show, some of the functionality that's upcoming and how powerful it really is. So for our seasoned users of ADAPT and who are familiar with the program, probably the next step with the modeling process or design process in this case would be to add distributed tendons, right? And so really, now hear me for a moment, we're going to go and take a trip down memory lane of how we would do this, right? We'd go ahead and click add tendon, and we'd go in here and start using our snapping tools, right? And for those of you who have done this, you're probably already groaning on the other end of the call going, oh no, is he really going to do this? And we know exactly just how tedious this process can be, right? I'd add a tendon like that. I'd probably add another one up here. I'd then go ahead and grab this tendon, which I'd often call as a master tendon, go over to my modify tab, and we can copy this guy, right? Maybe over 4 feet, and we do it, I don't know, 3 times, right? And we've already started to see a problem here, right? This slanted slab edge poses a problem, not a huge problem. Our trim extend tool would typically take care of that. But what I'd have to do now is then grab this tendon and move it and do something like this. And then, rinse and repeat, add some of our snap tools into the mix. So I don't have my high points. We can right click and start inserting vertices, and yada, 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 right? This is not exactly what I wanted to do, but you get the idea, right? This is not a fun process. And anyone who's had to do this can attest that this takes a while. This does take a while. And anytime you have some sort of change in geometry, kind of moving horizontally through the building in this case, is going to have to, or means that there's going to have to be a tendon change, right? We're going to hit this tendon at some point. We're going to have to add another high point. We're going to hit this jog in the slab, and we're going to have to trim the tendons back. And then there's going to be an opening, and we're going to have to split those tendons into 2. And that just takes a ton of time, right? So let's go ahead and delete these tendons. We'll kind of dive into the latest features. So I'm going to go ahead and open up our smart tools. Now, I'm going to take a slight detour real quick, right? We have all of our settings and default properties. And instead of boring you guys to death, going over all of these in great detail, let me make a quick little plug for that help menu I discussed, right? In the top right corner, we have this question mark, and we can click that real quick. And it happened to open up in my other screen. But here is the new help file within Builder. Super, super nice, right? For example, let's go ahead and jump to our tendon ribbon. And we were looking at our Smart Tendon Editor. And if we dive into here, check it out. We have all of the settings labeled, described in great detail, probably greater than I could do it. So this is a great resource for almost anything you need within Builder. And we're going to continue adding to this and making it better to help our users with Builder. All right. Okay. Enough distractions. Let's actually get into this, this awesome tool. So I'm going to go ahead and use kind of just these settings that I've set up already. I am going to use a trace construction line when creating tendons rather than having my tendons snap perpendicular to the slab edge, simply because I have this diagonal slab at the bottom. You can imagine if I had this perpendicular to slab edge and started drawing tendons, well, the tendon's going to shoot off in this direction, which is not what I want. So we'll do that. I'm also going to have tendons be cut at openings. And in the default properties, let's go ahead and just say, hey, I want, in this case, we'll have 2 strands per tendon that I model. So let's hop into the mapping tab, which is really where all the magic happens. We're going to start with our smart tendon section. So I'm going to go ahead and create a tendon. And this is really simple. Notice we have a kind of tooltip hint here as far as what to do. And then of course the program is prompting you up here as usual. So I'm going to go ahead and create a construction line. You can see that red line. That's kind of, I clicked once and now it's snapped to my cursor. And then I'm just going to draw this line through these columns and I'm going to get them as close to vertical as I can. And just like that, it added tendons for me. And it didn't just add tendons, but it added tendons with high points over my banded direction, snapped it to the slab edge and realized, hey, there's no slab here, so we're not going to run a tendon through there, and then added another tendon up here for me. Super nice, super easy, right? Compared to clicking and adding spans, adding points, manipulating, all of that. Now I could go through and just start clicking like crazy and adding tendons, which, you know, would be pretty quick, but I'm going to use something that's even faster. So I'm actually going to jump over to the other side of our slab and I'm going to add another tendon real quick. So I'm just going to try and get that as close to vertical as I can. And bam, we have kind of a starting tendon and an ending tendon kind of for the bounds of our distributed region, right? Now, we're going to hop on down to the next section within our Smart Tendon Editor. I could go ahead and have the program use fixed spacing for our distributed tendons. However, what's going to happen is it will do fixed spacing. Say if I'm going from left to right, it'll do fixed spacing all the way until it gets to the end, and then it'll just make sure that it's not, that last spacing is not larger than the spacing I've specified. So, which isn't a problem. Maybe that would be your preferred of, you know, having everything at a solid 4 feet, for example. But I'm going to go ahead and use the max spacing option. And what this will do is the program will figure out the spacing between these tendons and then subdivide it evenly for all of my tendons. Now, humor me for a second. Just reminisce about how painful it was adding the tendon there, and imagine if, you know, this came across your desk of, hey, today you're going to be adding these distributed tendons. You're probably groaning at this point, but with this new tool, watch how easy this is. I'm just going to draw a construction line through that first tendon and then the end tendon and click. And just like that, we have all of our distributed tendons added within the model. I have them set at 3 feet right now, which may be a little bit of a tight spacing, and we'll see some performance issues as I'm zooming in, but no big deal. Notice as I zoom in here, the program has not only added all of these tendons spaced evenly, it has added our high points everywhere it has detected a banded tendon. It has also detected, hey, this is a group of banded tendons simply based off of my 8-foot tolerance setting that I have set here. And you can kind of see that here as well, right? This is probably larger than 8 feet. So it's saying that these are now 2 different banded groups. And I can go ahead and change that. Obviously, this tool is amazing. It just saved me probably several hours of having to add these tendons. And, you know, though it has done that, I can make some edits because it may not get it perfectly. For example, maybe I want these to actually be over this tendon because this is just an add tendon and I want the high points over this main banded tendon. That's where we'll hop down into the points section of our tendon editor. We could go ahead and add extra points. For example, we could delete points, but in this case, let's go ahead and move some points. Now, this is not going to be the optimal tool for this, but I just kind of want to show you how it works. So I just click move, and then I, again, just draw that construction line near the points I want to select. And when I click, you can see I have all of those points selected. And right, this tool isn't perfect for getting these high points kind of all aligned along that tendon, but it's great for, hey, maybe I need to kind of just scoot all these tendons over. We'll go there, right? I can scoot them over. Super easy, but we're not going to do that. So I'm going to go ahead and use undo. we really want to use the align tool. This align tool is amazing. So we just draw our line simply through those points. You can see they're selected again. And then I draw a second line of where I want them to line up. So if I select that, you'll notice all of those tendons then snap to that line. And I could do something similar here. Super easy and super quick to make tendon edits. Now, for those with the quick eye may have noticed, hey, Nate, you ran tendons through this opening. And that's because this isn't an actual opening modeled within the program, right? This was just two slab regions modeled, and the tendons didn't realize that. But that's not a problem. This is an easy fix. So I'm going to go ahead and actually click undo a couple of times and get back to where we just had our kind of mapping tendons. And if we hop back over to the max spacing option, instead of just doing what I had done, I'm going to turn this option on for use mapping region. And this gives me a little bit more control over where the tendons are added within the program. So for example, we're going to go ahead and select those tendons again as the bounds. So I'm going to go ahead and draw my construction line through those. And then I specify a boundary for where these tendons can exist, right? So I'm going to say, okay, let's draw a boundary around here. They can all be within this region, but instead I'm going to stop short of this opening, and I don't want those tendons going into that beam, for example. And so I'll go ahead and just kind of add a cutout around that section and just click out here. And then when I'm done, I'll right click and click close end and accept. And we'll notice that problem gets rectified real quick. Awesome. So I hope you're as excited as I am with adding of tendons. I think this is going to save a bunch of work, a bunch of effort. You're going to be a lot more consistent with your designs with adding tendons because of this tool. And you may be asking, hey, what happened to all the tendon editing features? They're still here. In fact, we've added a few more. So if you go into the edit tab, you'll notice you still have the ability to edit CGS, right? For example, we can zoom in here. Again, we have quite a bit of tendons, so it's getting a little slow, but we go ahead and, oh, maybe we want 1.5 inches for this guy. And then we just simply draw a line through all those tendons and it updates them for us. Similar with strands, you'll notice, hey, look, everything's color coded, number of strands. We can change those as well, just graphically. What is new is the ability to change the effective force of tendons now. So this has been added in here. Mode hasn't changed, so this is just, picking between straight, spline, fillet tendons. You can change, anchors, all of that. That's not new. The span shape, though, has been enhanced to now include more than just, I think it was reverse parabola and straight. You can now do all of the different profiles that you want to do, right? So I can go ahead in here and I can change a profile. And I actually skipped something real quick. Let's hop back. And I pointed out these pore strips. So I'm going to close this real quick. And I wanted to show a quick feature about these pore strips. So I didn't want that tendon in there. So let's get rid of that tendon. This tendon also shouldn't belong. Let's get rid of that. But we have this pore strip kind of running horizontally through all these tendons, which, adding all those tendons is fine and dandy. But when we have a pore strip, that doesn't make our life easy. Well, with, again, the smart tools in here, we can go ahead and go into our modify and we can cut to region. And what this does is it will cut existing tendons to a specific region. So for example, I don't want tendons in this pore strip. So I'm just going to go ahead and draw kind of a box outline around this pore strip real quick. Right. And then when I'm done, close end and accept. And then the program will trim all those tendons back to that pore strip. Awesome. So sorry, I forgot to mention that. I realized that because I wanted to talk about changing span shapes. right? And for example, maybe I want some of these to be reverse parabola, or sorry, cantilever down. Super easy to do. Just change that, draw a line through it, done. And you can do that with all of these. So there's the new tendon features in a nutshell. Drinking from the fire hose, if you will, as far as this new feature. Let's go ahead and turn our tendons off since they're a little slow, which actually brings us to our other enhancement. Originally, we had to use our green eyeglasses, if you will, the select set view items, properly known as, to modify the display of elements, right? But we have now added this visibility tab, which is replacing that set view items button. And in here, you can quickly change the display of elements. So notice in the tendon section, we've actually split up tendons into banded and distributed options. And this is important for using those mapping tools within Builder. So let's go ahead and just turn the tendons off. Now, you'll notice some other potentially difference. This column, we now have a bottom and top option. So let's go ahead and go to the side. I'm sure if you're like me, there were plenty of times when, I do a punching shear check, or I had a planted column that kept pestering me, thinking, hey, my brain keeps telling me it's supporting the slab, but hey, it actually isn't. I would always have to go in here, select these, and hide the columns. Now you have the option to hide top or bottom, and this option is also available for walls. Unfortunately, I don't have any walls in this model, so that's why it's not shown here. This is dynamic. It's only showing what is in your model. Same with loads. Let's go ahead and go into an ISO view real quick, and we can turn on our loads. And oh boy, we got a few. Looks like we got some line loads, some patch loads, all of that good stuff. And we can kind of cycle through these different loads if we wanted to, right? We can see just our dead load, or we could see our wind in the P0 direction, right? All of this just to make life easier as far as seeing the different components within your model. So let's go ahead and turn off our loads. And speaking of loads, let's go ahead and hop over to our loading tab for our other new features. So we're going to hop into our load combinations window. Now, these are the default load combinations based off of the code I have picked in my criteria tab, right? But you'll notice something a little different in the bottom. We've gone ahead and added a load combination generator, and we have made some changes to our long-term deflection. Now, I'm going to talk about the load combination generator, and then I'm going to pass it off to Gary to dive deeper into what we've done with the long-term deflection calculations and all of that good stuff. So as I'd mentioned, there is wind load within this model. I've also added some earthquake load as well. So if I click the load combination generator button here, you'll notice here's the code I have selected, and we have the ability to kind of pick and choose what area of the code as far as load combinations are concerned that we want to use. So we can use serviceability, that service limit state load combinations, as well as ultimate limit state. I'll go ahead and keep those on. With our wind loading, we can have the program either use reversible or not. Let's go ahead and leave that option on. And for those of you who have who do wind design or are familiar with ASCE, I think it's chapter 27. There's that one figure that probably haunts a lot of our dreams, where there are 4 different cases of wind loading, and you start to then realize the countless permutations and iterations of what happens when you start adding all of these different cases and different directions of your wind loading, and then it makes it hard to really sleep at night when you're thinking about having to put these in. So you have the ability to input load combinations for X and Y, as well as X plus Y, either X and Y with eccentricity, as well as X plus Y with eccentricity. Let's go ahead and leave them all on just to kind of show the power of this. Again, seismic loading, we can have it be reversible. And then this option is used for, that modification of your dead load based off of, SDS and whatnot. So let's go ahead and click add and see what this does. And immediately you see the scroll bar skyrocket to a tiny little bit, and it might be running into a problem. Hopefully not. Uh-oh. Leave it to a live webinar. There it is. Awesome. So as you can see, within a matter of seconds, we have added 217 load combinations within the program. Now you'll notice some of these wind loads are set to no code check. This is just so that we can set up the appropriate factors when we start diving into the different iterations of all of those different wind cases. And so we can quickly kind of just scroll through here and you can see, yeah, we start using all of those no code check wind combinations within these wind combinations and rinse and repeat, right? And you can see all of these appropriate factors applied. And then, even within our seismic being adjusted as well for our SDS and all of that good stuff, right? So if we jumped over quickly into our analysis tab, you can go ahead and execute analysis. We can see all of these load combinations available for us when we'd go ahead and design. Now you might be wondering, hey, some of these don't add up. That's because some of those were set to no code check. So that is really kind of what I had for you guys concerning, tendon enhancements, visibility panel, the help file, and the load combination generator. So I'm going to go ahead and turn it over to Gary to talk about the long-term load calculation and deflection changes that we have made. So let me go ahead and get our presentation up and going. Go ahead, Gary, take it away.
Okay. Can you go to the first slides? Okay. Thank you, Nate. It's very exciting to see all these great features being added to the new v21 version of Builder. So in my part of the presentation, which is roughly the next 15 minutes, I will be talking about the long-term deflection calculation in the new version of the Builder. And I will be talking about the two methods that are available in the new version, namely the ACI Multiplier Method and also the ACI 209R methods. I will be talking about the equations being used, and at the very end, I will show a quick example of how the builder actually calculated all the multipliers in this calculation. So if you look at the criteria tab and the long-term setting in this dialog, I showed over here on the bottom. Now we have two options for calculating the long deflection. One is the ACI multiplier method, and the other one is the detail method in ACI 209. So based on based on different method you selected, we would ask you to modify the input. So if you select the ACI multiplier method, you will need to input the long-term multiplier, which is just a single value. If you have done the ACI method, you should be familiarized with this factor. And if you choose the 209 method, you can see we have a lot more parameters you need to define, including your creep factor, shrinkage factor, and also the type of curing you're done, either is moist or steam, and also the duration of the curing for your concrete. So after you define all these parameters, it will be plugged into the equations, and then you will get a multiplier being calculated automatically. If we can go to the next slides, Nate. So for the ACI multiplier method is actually a very popular method and widely used, and it's quite simple. So if you look at these equations in the red box, your delta LT, which stands for the long-term deflection, will be equal to your delta immediate times the factor lambda delta. So the delta immediate will be your immediate deflection due to or your sustained load. And then we would time a factor to calculate the deflection due to the long-term factors. So the lambda delta will be equal to psi divided by 1 times 50 rho prime. So in here, the rho prime is actually the compression reinforcement ratio. So if you have a continuous span, it will be at the mid-span. And if you have a cantilever, it will be at your support. So most of the cases, the compression reinforcement ratio will be 0 in most of the slabs. And then we would cancel out the denominator, and then your lambda delta will be equal to your psi. So your psi is defined in ACI as the time dependent factor for sustained load. So ACI gave this nice little table, which you can check based on your sustained load duration in month. And then you can find your psi factor. So if you have a 3 months duration, your factor will be equal to 1.0. And if you have 60 months or more, this factor will become 2.0. So if you want to know the factor between some of these durations, you can either do a linear interpolation, or ACI actually have a nice curve, which you can find this factor based on the duration of time. So one thing you should pay attention to this delta LT is these delta LT is the additional deflection due to the shrinkage and creep, meaning that this doesn't include the immediate deflection due to sustained load itself. It's just the additional. So for instance, if you have the immediate deflection due to sustained load equal to 1 inch, and then your factor psi is equal to 2, and then your additional deflection will be equal to 1 inch times 2 will be equal to 2 inches. Now, if you want to look at your total deflection, it'll be actually 3 times the initial deflection due to sustained load, if that makes sense. So this factor will be actually presented later on in these slides. So the factor will be the total one. So Nate, if we can go to the next slide. So the second method you can actually choose is the ACI 209R detail method. So as you can see that in this method, we have a lot more complicated equations than the previous one, but the main equations are actually pretty similar. So your delta LT, which is again your additional deflection due to long term, is equal to your delta immediate times a factor of C. So in this method, the C will be equal to the sum of 2 factors. One is the CR, the other is the SR. So the CR refers to the creep coefficient at the age t, and SR refers to the shrinkage coefficient at age t. So we consider these 2 factors separately due to creep and shrinkage. So on the right-hand side, I show the equation of how to calculating your CR and SR factor. As you can see that we have 2 different expressions for the moist curing or the steam curing. So based on what type of curing method you select in the previous dialog I showed, the program will use different equation to calculate the CR and SR factors. So here I highlighted all the input in green. So all the green parameters shown in the equation will be the input that we require the user to actually modify. So the CRU and the SRU equation, SRU factor are actually the creep factor and the shrinkage factor. You can define those in the dialog I showed in the first slides. And also here we have the T factor, which is the observation date. And then we have the T0, which is a concrete age at loading. And then we have the TC, which are duration of curing. So the T and T0 can be modified in the load combination spreadsheet, which I will show in the next slides. And then the TC factor, again, can be defined in the dialog in the long-term setting. So by, as you can see from these equations here, we have the T factor and the T0 factors. So just imagine that if you have a load that applied in stage, so basically stage load, so we would have a different CR and SR factors at each of the load that you apply. because the T will be different for each loading scenarios. And then you would have end up having a group of C factors for different loading stage. And in order to calculate the total long-term deflection, you would need to do this calculation stage by stage and get your final deflection. So I'll be showing an example in the last stage, in the last slides of my presentation to show you how the multiplier has been generated. So Nate, can you go to the next slide? So here again, as what previously Nate has shown in the demo part. So in the load combination dialog, if we look up at the first screenshot, here I define different loading stage for doing the long-term deflection calculation. So here, stage one, the analysis and analysis option, I would choose the correct deflection. And then the loading type is sustained load. So here is age at the loading is 20 days. And at the 20 days, we only have the self weight. So this basically represent when we remove all the formwork. So we only have the self weight of the concrete present. So we only choose one factor for the self weight. And at 40 days, which will be our stage two, the other options will be the same, but the age will be 40 days. And then we would add our additional data loading there, which would include the partitions and so forth. So at the stage three, which will be our 180 days duration, and then we will add our live load. As you can see here, we have a 0.3 factor for the live load, which essentially meaning that 30% of the total live load will be sustained, which is our assumption here at 180 days. And then at the very last, we have our total load, which basically include all the loads. And if you look at the second screenshot I had here, we needed to define also our long-term deflection load combinations. So here in the analysis and design options, we would need to choose the long-term deflection option. And then the third column here is the deflection calculation, the deflection factor calculation option. So here we would choose all do so that the program will automatically calculate these factors. Here you can also choose the user input. So you can just manually input all these factors and the program will use the factor you input instead of auto calculate it. And then the observation date, which if you recall would be the T in the previous equations, we will define as 40 days, 180 days, 360 days, and also 5,000 days. So in the first one, 40 days, as you can see, we include the stage one load and stage two loads, which will be our self-weight and dead load. And then in the 180 days, we will include the additional live load, and then the 360 days, we will include the total load, and then 5,000 days will be the total load as well. So if you look at the third screen that I have in there, so after we define all those, we can click the calculate long-term factor button, which is next to our load generator button, which previously shown in the demo. So after you click that button, the program will update all the values you put in the second screenshot, which was initially they were all ones. And then now it becomes some values that are different for different different load combination. So what does this mean for all these factors? So these are actually the multipliers that will be used to calculate the deflection at each stage. For instance, if we look at the long-term deflection at 40 days, so we have a load multiplier equal to 1.019 for stage one, and a multiplier equal to 1 for stage two. So what this means is that your total long-term deflection at 40 days will be equal to 1.019 times your deflection at stage one plus your plus 1.0 times the deflection for the load combination stage two. So this multiplier will be used to multiply each individual stage deflection in order to get the total deflection at that stage. So I will be showing an example in the next slides. Nate, can you go to the next slides? So in this final slides, I showed a calculation example at the 5,000 days. So as you can see from this table here, in the 5,000 days, we have different stages. So at stage 1, which is 20 days, we can calculate the long-term deflection factors, all the CR and SR factors. Here, my CR factor is 1.945 and SR is 0.497. So using these two factors, we can calculate our total C factor, which is the sum of these two, equal to 2.442. So here I call it C1 because it's for stage 1. So we can do the similar thing for my stage 2 and the stage 3. I would end up with the 3 different C factors. So if we wanted to calculate the long-term deflection at the 5,000 days, it would be equal to the deflection at stage 1, which will be equal to my stage 1 deflection, which will be my immediate deflection due to sustained load, times my C factor, which is 2.442, and then times my immediate deflection again, which is the stage 1 deflection. So the stage 1 plus 2.442 times stage 1 will be my total long-term deflection at stage 1. And then when we come to the stage 2, the immediate deflection due to sustained load will be equal to actually stage 2 minus stage 1. These represent the additional load that was applied at stage 2. So this will be my, the stage 2 minus stage 1 will be my immediate deflection, plus, similar idea, 2.289, which will be my C2 factor, times the additional load that's been applied in at this stage, stage 2 minus stage 1. So using the similar idea, I can do my stage 3 minus stage 2 times C3 factor times this term, plus the total load minus the stage 3. So as you notice that at a final stage, which is the total load stage, we don't have that C factor being applied. That's because at the total load stage, we don't actually have any additional sustained load being applied. So all the sustained load has been already applied in total at stage 3, which is equal to 180 days. So if we combine all those factors for this stage 1, stage 2, we can have a final equation, which is equal to 0.153 times stage 1 plus 0.293 times stage 2 and so forth. So in here, we can see that we have a final factor being applied to stage 1, stage 2, and stage 3. And those factors are actually the factor the program calculated after you hit that calculate button. So as you can see here on the bottom of my slides, those factors has been automatically updated for those different loading stage as multiplier. So as you can see that these feature for automatically calculating the factor are very, very convenient for you if you want to do this in different stages. You don't need to actually manually calculate all those and then apply all those manually. And also, if for any case you want to change your state duration, and also if you want to change your CRU factor defining the dialog, you can just come back to the load combination dialog and hit the button again, and it'll automatically update all these factors, very quickly. So, and with that, that concludes my presentation. I think I'll hand it over back to Nate.
Awesome. Thank you so much, Gary. That was great. And thank you everyone for your attention during the webinar. We'll give you 15 minutes. It looks like about 15 minutes of your day back. So you are welcome. Thank you again for attending, asking any questions that you had. We hope you learned something new today and that you're as excited to use the latest version of Adapt Builder as we are. In the next few days, you'll be able to find the recording of this webinar on our YouTube channel if you want to refer back to it for whatever reason. Should you have any additional questions or want to learn more, I invite you to email us at info@risa.com or visit our website at risa.com. Thank you again so much for joining us, and I hope you all have a great rest of your day.